So guys, let's remember the basic graph of the sine function according to the videos that you saw. This is one with an amplitude of 1, a period of 2 pi, the endpoints at 0, 0, and 2 pi, comma 0, domain from 0 to 2 pi, and the range from -1 to 1, with an average y value of y equals 0. Okay? According to the colors, let's remember these. Please, A is the amplitude, B is the denominator of the period, C is a horizontal movement, and D is a vertical shift. The formulas that we are going to be using for the endpoints are bx plus c equals 0 and bx plus c equals 2 pi. You take this directly from this part of the equation without changing the signs. Please remember that. It's very important that you remember that. Okay? Putting all of this information together, the instruction is sketch the graph and determine the endpoints, period, amplitude, average y value, domain, and range in one full cycle for the equation y is equal to 3 sine of 2x plus pi. So the first thing that we're going to do is determine the amplitude and the elements that we need in order to make a box. We are going to be making a box that encloses this area of the graph. As you saw, these ones are periodic functions and they continue positively and negatively in any direction indefinitely. Okay, that's why they are called periodic functions. So let's begin with this. Okay, as I said, it says here, the amplitude in this case is 3. Okay, the b, let's remember that b is a value, this value, that is always going to be multiplying the x. It's a coefficient of the x, so in this case the b is equal to 2. Therefore, our period is 2 pi over b. That is equal, in this case, 2 pi over 2. I cancel the 2, so my period is going to be pi. In one full cycle, this graph is going to go all the way up to pi. The endpoints, bx plus c, here is plus, bx plus c is equal to 0. Remember that I take this part of the equation directly without changing the signs and solve for x. So bx plus c is equal to 0, which is 2x plus pi equals 0. This means that 2x is equal to minus pi, x is equal to minus pi over 2. Then 2x plus pi is equal to 2 pi. 2x is equal to 2 pi minus pi. X will be equal to pi over 2. So this means that this graph in the x-axis will go from minus pi over 2 to pi over 2. That would be my period. Remember that my period was pi. So this graph is going to be taking from minus pi over 2 to pi over 2. Let's remember that the basic graph of the sine function goes from 0 to 2 pi in one full cycle. According to what I got in the endpoints, my graph is going to begin at minus 2 pi and end at pi over 2. Why is this? Let's remember from math, your previous math courses, that this part over here, if this is going to be giving me the horizontal movement and it's a plus sign, whatever is adding to the x inside of the parentheses, remember that it's going to go in the opposite direction. So if this is a plus sign, this means that the graph is going to be shifted to the left from where it started, which was 0. How many units? Pi over 2. That's why we're getting the endpoints. While you're doing the endpoints, while you're getting the endpoints, you will not have to worry to calculate this. You only need to know if it goes to the right or to the left, because when you get the period and we enclose this with the endpoints, the horizontal movement that the graph is going to be having is going to be done automatically. So I have my coordinate plane already with the scales that I need, and the first thing that I'm going to do is determine, obviously I'm going to locate these endpoints in my graph. According to what I have, my graph is going to be beginning at minus 2 pi and ending at pi over 2. I'm sorry, beginning at minus pi over 2. Okay, my amplitude in this case was 3. Remember that these graphs are symmetrical, so whatever amplitude I count to the upper part of the graph, I will also have to count to the lower part of the graph. Actually, the amplitude is always an absolute value. I always consider it in positive, and I go upward and downward. Upward and downward from where? From this part over here, this over here, which in this case is my average y value. Now, if I remember the basic graph, this d was going to be giving me the vertical movement of the graph. In this case, I don't have a d, so I can say that it is plus 0. it is up plus 0. I don't have vertical movement. The average y value is going to be on the x-axis over here. The graph is not moving vertically, only horizontally. So my amplitude is 3, coming back to this. That means that from the average y value, which in this case is the x-axis, from the average y value, the x-axis, I am going to go 3 units up and 3 units down, okay? So once I have, that's the box that is going to be enclosing my graph. The only thing that I have left to do is locate the center of this period. See, the center of this period is obviously the y-axis, exactly at the middle of it is at 0. So from there, I will just locate half to one side and half to the other. If you notice, I am splitting the graph in 4 parts. Again, I put the endpoints. I trace the amplitude and split my graph in 4 parts. Okay? Always locating the center, which in this case is the y-axis. The center of the period from minus 2 pi to pi, it's 1, so half of it is obviously at 0. Okay? So, coming back to this, once that I have my box, I made it a little bit less messier, split into 4 equal parts from beginning to end of the period. We stated that my endpoints were at minus pi over 2 in x and minus pi over 2 in y. Later on, we're going to get the coordinate with the y value. For now, we only obtain the x value. I have my coordinate plane split in 4 from minus pi over 2 to pi over 2. I determined that the center of my graph, or the middle of it, in the x-axis was at 0. Now let's remember the shape of the original sine function. If you notice, I begin at 0. In this case, it's the endpoint 0, 0. I go upward. In the first quarter, I reach the maximum and then decrease to the middle part of the period, and then on the third quarter I reach the minimum and then back again to the end of the period. That's why it's important to split it in 4. If you notice, I have 1/4, the second fourth, third fourth, and the last one from beginning to end in one full cycle. So that's exactly what I did. That means that my graph is going to begin at minus pi over 2. In the first quarter of the graph, it's going to reach its highest. Then it's going to cross again or reach the average y value again at the middle of the period, and then come back down to the third quarter and then up again to the other endpoint. So what happens here is that I am going, just tracing the points with the basic shape of the sine function. And this is going to be the graph that represents the given problem at the beginning, which was y is equal to 2x plus pi. Y is equal to 3 sine of 2x plus pi. That was my original problem. So y is equal to 3 sine of 2x plus pi. This is the graph that represents it. Now let's finish getting the information. The points, let's remember that from bx plus c equals 0, I obtained that x was equal to minus pi over 2, and that from bx plus c equals 2 pi, I obtained that x was equal to pi over 2. So if I talk here in terms of coordinates, this I will be having, my first coordinate is minus pi over 2 comma 0, and the last coordinate or endpoint would be pi over 2 comma 0. Why is that? Remember that these bx plus c things, these two, are these points in the graph, the beginning at the end of the graph. So that's why the coordinate of y is 0. These are the endpoints that we are looking for. What we get with the formula is just the x value of the coordinate. I hope we're clear with that. If not, you can go to the recording of the session and you can repeat this video again. Now let's finish getting this. I already have the amplitude, the period, the endpoints, I already got them. The average y value, I have to get the equation of the average y value. The average y value we stated that was at the x-axis over here, so average y value, it's an equation, so it's at, the line is crossing the y-axis at 0.0, y is equal to 0. The domain in one full cycle goes from negative pi over 2 to pi over 2, and the range, which is obtained from the maximums at the minimums, go from negative 3 to positive 3. Remember that the range is from minimum to maximum, and the domain goes from left to right. So So the highest point is positive 3 and the lowest point is negative 3, which give us our domain and range. And actually the domain and the range come out from the endpoints of the graph that I obtained with bx plus c equals 0 and bx plus c equals 2 pi. Okay, so to wrap this thing up. Sorry, I had written a parenthesis. It's a bracket. These values are included in the graph, so they have to be enclosed in brackets. So this is the complete problem. I hope that you have a good view of it. So the graph of 3 sine of 2x plus pi is this one, with a horizontal movement of pi over 2 units to the left, according to what I got with the endpoints. Remember, the endpoints are going to be giving us the horizontal movement of the graph, or the phase shift. Later on, we are going to talk about the phase shift. That we will leave for later. Okay, so let's continue with another example. Thank you.